let's see. I'm on page 6. Good. So I have FB. So I'm differentiating with respect to B, and M is kept constant. So this is 0. I'm differentiating with respect to B, so this is minus 2MB. This is... Yes, of course, of course. So I'm sorry. Let me start from the beginning. So I'm differentiating with respect to B, which means M is a constant. This does not have B in it, so it's 0 when I differentiate it. When I differentiate this with respect to B, I get negative 2MB. When I differentiate this with respect to B, I get negative 3. When I differentiate this with respect to B, this is the only variable, I have positive 2m plus b minus 8, but times the inner function prime, but this is 0 and this is 1. So I'm going to write 1 so you know where it's coming from. Plus, I'm differentiating with respect to b. 3m plus b minus 9 to 2 minus 1 times 1, because when I differentiate b, I get 1. Of course, you can omit the 1. So I'm going to continue because I need to, and it's possible to hopefully to simplify it a little bit. Negative 2mb minus 3 plus 4m plus 2b minus 16 and plus 6m plus 2b and minus 18. Okay, so let's see what I can do here. I only have a negative 2mb, but I have this and this and this. So this is negative 34, negative 37. Then I have positive 10m, and then I have positive 4b. So this is it. Now we are also asked to find fm, meaning b is fixed, and I'm differentiating with respect to m. So when I differentiate with respect to m, I get 10m. This with respect to m, I get negative b squared. This with respect to m, nothing. This with respect to m right here now. So positive 2m plus b minus 8 times the inner function prime, which is 2 because these are constants, plus what? Plus 2 times 3m plus b minus 9. When I differentiate the inner function, I get times 3, because this is 0 and this is 0, because I'm differentiating with respect to m now. Nice pick. Okay, so then it's 10m minus b squared. This is, I'm multiplying by 4, plus 8m plus 4b and minus 32. And now I'm multiplying by 6, plus 18m plus 6b minus 54. Okay, so I only have negative b squared. Then let me continue with the b's, plus 10b. Then I have 18 plus 18 plus 36m. So these are accounted for. And then I have minus 86. And this is it. The first partial derivative with respect to m. Any questions? I would like to look at a word problem and see what they're asking us to determine. Let's look at life and physical sciences. I don't know, temperature, humidity, heat index. This is interesting. Let's see what they want us to do. Because I think the question is on the other. So what do they want us to do? Just find the rate of change, or let's go. Let me go back. Temperature, humidity, okay. Heat index. In summer, high humidity interacts with the outdoor temperature, making a person feel hotter because of reduced heat loss from the skin. The temperature humidity index T sub H That's it. The function is what the temperature would have to be with no humidity in order to give the same heat effect. One index often used is given by, okay, where T is the air temperature in degrees Fahrenheit and H is the relative humidity, expressed as a decimal. Find the what? Temperature humidity index in each case, round to the nearest tenth of a degree. So this is just plugging in. They're not asking us to differentiate. Use the equation, okay, aha. Given above for exercises 49 and 50, for these two, find the age over dt over dh and dt over dt. So I wouldn't use the same tt, but anyway, and interpret its meaning. Okay, is this interesting for you, or you want to choose something else? Anyone? We want to choose something else, or is this okay?
That's okay.
Okay, so let me copy the function, and we would like to look at 49 or 50, doesn't matter. So let me copy th.
49 is fine.
Okay, 49. So for 49, they want to find the partial derivative with respect to h. Okay, so let me go back and copy the function. So t of t and h, okay, is 1.98 t minus 1.09 1 minus h t minus 58 and minus 56.9. Interesting function. Okay, good. So one option would be to distribute these or not. It doesn't really matter. So we want to differentiate with respect to age only. So this is the only variable. This is a constant, this is a constant. So this is the only thing I need to differentiate carefully, right? So this prime is 0, this prime is a constant, it's 0. So these two are constants, so I'm going to put them in front. And then simply differentiate this because this is a constant, stays in front. When I differentiate this, I get -1. And this is it. So this is 1.09 times t minus 58. So what is the meaning of this? If we keep the temperature constant, the function differentiated with respect, or the rate of change of this function with respect to the heat index, I think it is, depends on the temperature only. So give me the temperature and I'll tell you at that particular temperature what is the rate of change of this function with respect to h. But you have to give me the temperature. And then I'll tell you at any temperature, at any instant, what is the rate of change of the function. Any questions? H is the relative humidity. So the rate of change of temperature humidity index, TH, when the temperature is kept, right, when the air temperature is constant, but you have to give it to me, and I'll give you the answer, and H is the relative humidity. So the rate of change of temperature humidity with respect to relative humidity for any temperature, T. Okay, so I'd like to talk about the last section, and we're going to have a full session on Tuesday next week to review for the test. Do you want to look at more problems, or you want to see the last topic, finding max, min, relative max, relative min for functions of several variables?
There was one question on the next page.
Yes.
That I don't remember the number. Yeah, it was one of the synthesis questions. Is that something?
Which one?
I think it was 61.
This one here?
Mm-hmm.
Okay, we want to look at that to find fx and ft. What's 61? Yes?
Yes.
Very good. So let's do that. So which one would you prefer, either ft or fx? Which one would you want? I'm just going to copy the function.
F of x.
Okay, fx. So it's not f of x, it's fx, which means the partial derivative with respect to x. Good. Okay, let me check that I copied it correctly. 6 times x to 2/3 minus 8 x to 1/4 t to 1/2 minus 12 x to negative 1/2. Yes, t to 3/2. I got it. And we want to find fx. Good. Excellent. So in order to find fx, this is not f of x, it's just fx, which means the partial derivative of f with respect to x. So t is kept constant. So here I differentiate with respect to x. 6 times 2/3 will be 12 divided by 3, which is 4. X to 2/3 minus 1, which is negative 1/3. The next term, we differentiate with respect to x, and t is kept constant. So 8 times 1/4 will be 2. So minus 2x. 1/4 minus 1, negative 3/4, and I have to copy t to 1/2. Final term. I bring negative 1/2 and I get positive 6. X negative 1/2 minus 1, which is negative 3/2, times t to 3/2. And that's it. This is fx, meaning I differentiated function f with respect to x, keeping t constant. Is this okay?
And with this question, when you then find f in regards to t, you're using the original equation, right? You're not using...
No, yes, of course.
X.
Yes, but
You're
if I
always
want to
okay.
find fxt, then I have to use this.
Okay.
Right, but if I want to find ft, it means that I differentiate this function with respect to t, keeping x constant. Yes, I have to go back to the original one. It's the original. Here it's no longer the original, right? So I have to have fx first to differentiate it now with respect to t. Is that better?
Yes, that makes sense. Thank you.
Great. Okay, the last section, again, we can go back to any problems you want. 6.3, finding max min for functions of several variables. Okay. Well, in our case, we're going to look at functions with 2 independent variables. Finding max min. Well, there is something called the d-test. And let's talk about the d-test and apply it. And that's it. Apply it in word problems or any other type of problem, just regular. Okay. So here's what the d-test is saying. In step number 1, we have to find fx, fy, fxx, fxy, fyy, fyx. Once I determine all these, in step 2, I create a system. This is a system of 2 equations. And here is the system. Fx equals 0 and fy equals 0. This is not surprising, right? Because that's how we determine critical numbers for regular one variable functions, right? We find the derivative, we set it equal to 0. So this is not surprising, right? You're not surprised to see that in step 2, we have to create a system and determine ordered pairs, x comma y, that fulfill this, if any. There is no guarantee, but I'm looking for ordered pairs this time. Okay, in step 3, I calculate this D number. And the D number is calculated like this. So let's say here I get not x, y, because I'm just going to name them. They're numbers, right? So let's use a comma b. It doesn't matter. You can use c comma d. But let's suppose from this system I obtain a point or points. I can have more, but I have to determine the d for all ordered pairs that solve the system. So how do I determine this? fxx evaluated at a comma b multiplied by fyy evaluated at a comma b and minus fxy evaluated at a comma b, but this has to be squared. In step number 4, I draw a conclusion. And the conclusion is based on D and fxx. So if D is a positive number, because this will be a number, I have to calculate this number for every ordered pair. If D is a positive number and fxx of a comma b is a negative number, then the conclusion is that a comma b is a relative max. If D is a positive number and fxx at a comma b is a positive number, then a comma b is a relative minimum. If D is less than 0, a comma b is called a saddle point. If D equals 0, test not applicable. So these are the 4 possibilities. So if D is a positive number and fxx, this number here, is positive, then at that point, the function of 2 variables has a relative minimum. If D is positive and fxx at AB is a negative number, that is a relative max. If D is less than 0, it's not a max, it's not a min, it's a saddle point. I'll show you a picture in a minute. If D equals 0, then the test is not applicable. No conclusion can be drawn from it because we can't apply it. Okay, let me just share for a second and go back. Forward, of course. I want to show you. We know what the saddle point looks like. So these are the relative max, relative min for a function of 2 variables. So that's an example. And this is the situation in which D is 0. So at this point, the function does not have a max, does not have a min. It goes lower than it, and it goes higher than it. So this point, that is the saddle point, doesn't mean anything. As in terms of max min, that's what I meant. Okay? So this function, right? Any questions? So let's see how we apply the test. Go through all these steps. I like the graphs in this book, in this section. Okay, so here we have just abstract just to practice to find if these functions have max, min, relative max, relative min. And then we're going to look at, as you see, functions of two variables to find their max or min. Okay? And these are the applications. And that's it. So this was 6.4. So let's start.